Hello, Elaine. How are you?
Hi, trying to get the right buttons pressed so I can talk.
Yeah, tell me about it.
Yes, I am good. How are you?
Well, not too bad. Very busy. Say, so is your
Excellent.
office in Building 801?
That's my home base. Yes.
Oh, right. So you're working remotely some of the time?
Yeah. Are you familiar with our 801 building?
Oh, yeah. I worked at actually out of Hawthorne for about 2.5 years.
Really? When?
Let's see. Middle of 88, right after I got my doctorate, until about the end of 1990.
Really?
Yeah, then I went over to
Where?
USC and was on the research faculty for a while.
Oh, cool. And what group did you work in when
It
you were
was
at
called
Hawthorne?
hybrid data flow.
Mm,
I think it folded probably 6 months or so after I left, early 90s, and I'm not sure how many of the people stayed there.
oh,
Probably at least one. Is Katamuri Ekanatem still around? I think he was
mm,
probably like 50 back then, so he's probably retired.
doesn't ring a bell. Mm,
Okay, right. Yeah, he'd gone to I think ETH in Zurich, and he'd been
mm,
at IBM for a few years before he joined that group I was in.
well, that's cool.
Yeah.
So you were in the computer science department.
Yes. Yes.
Yeah. I started out in manufacturing research and then
Oh.
moved into computer science. And
Oh,
so
I
we were in
see.
Hawthorne, you and I were in Hawthorne at the same time, but we didn't know each other.
Right. Well, it was a pretty large building.
Yes, the one where they had to bring the computers in through the roof or the window or whatever it was, the
It
roof, right?
was. Oh, yeah. It was the
Right.
roof, and you remember
Yeah.
the 390 systems on their had the text graphics with the screen
Yes.
lowering the. Yeah.
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 Yes.
It
Yes.
was hilarious.
Mhm. It had expanded quite a bit into what was it Eastview? There was another
I
site
Oh,
and
I don't know.
yeah, Eastview and Yorktown, of course.
Yeah. And now everything's pulled back into Yorktown, I guess.
Yorktown. It's all
Right.
back in Yorktown now.
Right.
And they took all of the computer centers, I guess, because the different departments had their own, and then there was one
Right.
for the billing. All that went up to Poughkeepsie.
Hmm.
Yeah. So they have a clean room still, and but a bit of the chemistry stuff, but anything that could have been moved to Poughkeepsie
Right.
went. Yeah.
Right. Yeah. During my last year, they were starting to focus more and more. I think what it turned into was they wouldn't have any research projects that weren't directly tied to a development project. I
Oh
think
my.
they went too far the other way. Yeah.
Yeah, that was too far the other way. But it always does do
Yeah.
back and
Back and
forth.
forth.
Yeah.
Oh, it's time.
It is. I better get my display ready here since I'm on stage here today.
Oh, sorry to delay you.
Oh, yeah, it's okay. Waiting on Jeff anyway.
I just sent you an email. I don't know if you had a chance to check it.
I did. I just saw it.
Thank you.
Yes. Yes, makes sense.
Thank you.
If I can share screen. Wow. I have the share screen button. Maybe I should go ahead and at least display our questions. Hey, Brian, are you running the show today?
Hey, I am, but I'm not going to be able to stay for too long. I have multiple conflicts this morning.
Oh boy.
But I understand you and Dark are going to go over the secure BMC.
Mhm,
Uh,
that's right.
so I do look forward to it. And we are recording. Um, so yeah, please take us away whenever you're ready.
Okay. Can you see my screen?
I can. You've got a specification open.
I,
A document, yes.
I have some questions and answers. I know Microsoft Word file. Okay, so let's see. For those of you who may not remember, because we did this a long time ago, we started it. Darpana and I and a few others have we're concerned about the state of BMCs and the security of them. And we thought it might be a good idea to sort of put together a specification, a white paper, whatever OCP is calling it these days, that describes some security requirements for BMCs, at least strong recommendations that BMCs should follow, security-wise. As we started into this, we looked a lot at OpenBMC and compared our notes from our own companies as input, and immediately hit a wall with lots of questions because there are so many variations already in the market on what BMCs do and how they do it, and their in particular their interfaces, the roles, their restrictions, their stacks. It's just a lot of variations, way more, I guess, than I expected when we started this task. So we left off last on this topic, trying to answer some questions that we came up with to try to guide the work. I mean, there is a draft out there, and Alberto has made some good comments in there for us to look into. But these blue questions today are what we really want to cover today. Number 4 is about TPMs. So the BMC, of course, is going to have to attest its own state, right, to the whatever it is, management or the system it's in. And one of the questions that came up is, what kind of attestation are we going to support? Do we need a TPM? Do we need a discrete TPM, a firmware TPM, no TPM, a partial TPM? And the question is, okay, well, yes, we do need something TPM-like for sure. And what kinds of commands should it support? If it's TPM-like, should it support the whole suite of TPM commands? Should it be a subset of them? And if it is a subset, which ones? And that's what our question is today, which is the first one, number 4. And the second one, which is number 8 here, and it's related, is, okay, you've got to support attestation. You've got to have some kind of hardware root of trust, TPM-like thing with commands that it can accept and respond to. And if it's doing attestation, then how much is it going to do? Is it just the BMC's firmware? But the BMC, as you know, can support a whole stack inside. It can be running Linux inside. It can be running in a custom OS. How much should it attest to? So I'm opening the floor to questions. Let me start though with Darpana, who has some input from Microsoft on number 4.
Yeah, thanks so much, Elaine. I think from our vantage point, right, like I think we discussed whether or not we just have like firmware measurements, we extended up the full stack, and I think we're definitely recommending strongly to kind of have full stack attestation. I think that's one. And from the TPM point of view, I think it's less about discrete or firmware, but I think that can be up to the implementation. But we're recommending the TPM 2.0 and the full stack, the mandatory set of commands. Now you can argue on this whether or not it makes sense to have the full stack or not, or you want a subset of this. But I think there are various TPM 2.0 compliant stacks out there. From a compatibility standpoint, I think it's easier to just kind of include the stack as opposed to say, okay, for this implementation, we're only going to use, a subset of 2.0. There are also test suites out there that kind of, are checking to see if you're TPM 2.0 compliant. Those will also be in their entirety. So like leveraging what's out there in the ecosystem from an open source perspective, I think is going to be helpful. And if you strip it down from what the specification is for 2.0, I think it's harder to do that than it is to include it all. So kind of our recommendation is go with the TPM 2.0 and have full stack attestation and use the mandatory commands there. That's kind of our point of view. So open to thoughts and etc.
Okay. Helpful. Anybody else have thoughts?
So, I mean, I agree with everything Darpana said. One thing that I think is critical for this kind of stuff is to specify the relationship between the root of trust and the TPM in this context, right? Specifically, we have used TPMs from a system software point of view to measure the boot environment, right? We measure the bootloader, part of the BIOS, and then the operating system. Each one of those layers kind of measures the next one, right? And then we have to prove that the first thingy that is measuring using the TPM is secure, right? We call these things ACMs, right? And we have some very clear defined rules for how those things run and how they're protected and so on and so forth, right? I think in this case, if we have a root of trust, the root of trust may take the role of that ACM maybe, right? So that it kind of protects the bottom layers, and then at some point it gives control to a layer that is going to start using the TPM, right? Maybe that's something that we need to specify.
Okay. So then if you do that, then when you get to attestation, how do you combine the two?
So I think that for the attestation stuff, if you're the use of the TPM, in my opinion, is for the higher layers, right? And in the OS, or to protect keys or certain things that you need to protect on the higher layers, right? Using sealing or whatever functionality like that, right? So then I would say for the upper layers, they just see the TPM, right? And what you're using the bottom, the ROT for, is to guarantee that the first layer that is using the TPM is secure, right? Just like the ACMs that do with like the BIOS and that kind of stuff.
Interesting.
Right. So now when you're, so there's two things the way I see this, right? There's the use of the TPM sort of at runtime for protecting stuff and so on and so forth. And there is the verification of the integrity of the image that is going to be used for the TPM, right? I think the verification of the integrity of the image is something that the ROT will do. Yeah. Right, which is you go, you measure the binary, so on and so forth. You compare it to some reference, and then you make a determination as to whether or not that's what you want to allow to boot, right? Once you allow the boot process to continue, then it sort of becomes a TPM thing, and anything that is running on top of that just uses the TPM and its interfaces.
Right. Yeah, I agree with mostly everything you're saying, right? I think what it comes down to is you're saying first mutable code. There has to be trust in first mutable code that actually, is responsible for loading the TPM related code, and then I can trust that piece, right? That's, I think, what
exactly. Yes.
Yeah, so I agree with you. I think in the specification that we're looking at, kind of, if you look at some of the questions we had down below, I think we went through this once before, but we would look at a true root of trust like piece, which is what you exactly said, right? Like instead of the ACM, it's going to be a root of trust, and it's based in strong identity, cryptographic identity, right? And I think once you have that, then you can ensure that the integrity of the TPM is actually in place and intact. And once you have that, then of course you can rely on the TPM for its functionality during runtime. I think that's kind of your overall kind of message, correct?
Yes, that's exactly it.
Yeah, and I think we're aligned. I think from our Microsoft point of view, I think we're aligned on that approach.
So where does the measurement of the code that uses the TPM go? Where's the measurement of the first mutable code? Where does it go, and does it get attested?
That would be part of one of the measurements that the ROT returns, right? And it get attested, for example, using SPDM as an SPDM responder.
Ooh, okay.
Or I was going to say, isn't TCG working on some way of binding dice to TPMs to solve the same problem?
I think, I wish Jeff is not here, right, today?
No, he's not here today.
Because he's the one, I've attended a few of those meetings. And so the use of that technology was primarily for protecting against interposers on the TPM.
No, I thought there was some other plan to use dice identities for like TPM EKs.
Yeah, so Matt, there are two things. Yeah, one is what is called kind of the idea of being able to attest to the TPM firmware. That's one thing, using dice or something else. And there is another effort in TCG, which is about having the TPM potentially being a TPM responder and then creating a remotely attested channel. And that's effectively the TCG part of Project Kirkland that has been presented at OCP.
But what we were just talking about above of like, how do you attest the root of trust that's using the TPM, I think is really the same problem as how do you attest the TPM firmware, right? Like if you have an FTPM, how do you attest the FTPM itself, which is a very similar problem?
Yeah, I think there's two pieces, right? And I hadn't talked about attesting the TPM, but that's necessary, right? So there's two pieces. One is attesting the integrity of the first mutable code, which is in theory the code that may start using the TPM, or at least that will launch a layer that will start using the TPM. And then the second one is attesting the integrity of the TPM itself. Right, I think you need to do both.
Yes, although if you're running a firmware TPM, those might be the same thing.
Maybe, yes. But architecturally, we should keep them separate, right?
Yeah.
This seems kind of messy from an infrastructure point of view. You've got to know what your BMC has inside of it that's going to respond at the station. It could potentially be three layers, right? Or at least two.
Yeah, the way I see it is you have to look at the BMC the same way you look at the host processor, right? When it comes to TPM and roots of trust, right? The first one is how do you figure out the integrity of that hardware and firmware, right? And then the second one is once that hardware and firmware is running, how do you support all of the other stuff that the CPM allows you to support? And some of those things may be providing evidence of the integrity of some of the upper layers.
So would you assume then that every BMC must respond to an SPDM request for measurement?
Yes, but that request for measurement doesn't necessarily talk about the runtime environment or doesn't
Right.
talk about the runtime environment, just about the bottom layers. And then the uses of the TPM on top of that tend to be more environment specific. I don't know if we want to standardize that, right? But today they aren't, right? It depends on the OS, it depends on a bunch of other stuff.
Well, then we're saying, okay, at a minimum, every BMC must respond to SPDM and it must respond to TPM.
Well, I wouldn't say that you can't require both SPDM and TPM, because again, depending on the implementation, you can do everything using SPDM or do everything using TPM. So we need to provide flexibility for both. Because exposing TPM measurement in SPDM is not something that is natively support, I would say.
Right. The other thing that is, I agree with that, right? The other thing that is interesting here is the SPDM responses are external to the device, right? Somebody outside asks for the information and so on. TPM responses are sort of not external to the device, are to code that runs inside of that device, the way I see it. Right?
They always
Yeah.
were, that they were coming from, the quote requests are coming from the outside to verify it.
Well, but you typically have, like, if you want to do verification outside the platform, you have an agent, right? Yeah, and then there's a protocol between that remote verifier or whatever it is and the platform, right? But that protocol is not TPM. It's some protocol for them to talk about to pass TPM information, right? The TPM information is between maybe that agent and there is some driver in the TPM or so on that gets you to information from the device.
Yeah,
Eventually you get to the TPM protocol at some point.
yeah, but it's through the processor running OpenBMC or something. It's not from an external entity to the BMC.
Right.
I guess my question is, if the BMC supported SPDM, what is connected? Like, how does that connection work? What's making that SPDM call? What interface is it going over? Because usually it's the BMC initiating the SPDM quote requests. And if the BMC needs to support that, like, who is the agent making those requests? And then after we answer that question, we start over again asking, how do we secure that agent?
For these, for this purpose, meaning the BMC security spec, do we care what's asking?
Yeah, I would say that that's outside scope. That would be my preference, right? You can talk about the secure interface on BMC and potentially say that that's within scope, but where it's coming from, every architecture is going to be different, right? And I don't know if we want to specify the security posture of the agent that's requesting the measurements. At least that's my viewpoint on the document that we're trying to write. I don't know what you think, Elaine.
Well, I guess my question is that I expect there are platforms that there is no other agent to query the BMC. Back to the, do you require it? I'm not sure you can require it if there's nothing there to use it.
Yeah, so I guess let me ask you this question, right? Like there has to be a way to attest the BMC, any measurements that are coming out of the BMC. So no matter which application you're in, of course, in our world in Microsoft, we do have a way to get those measurements out. But I'm trying to be, kind of open about what else is out there. If you do have measurements and you do want to attest, there has to be a way to get them out in some mechanism, right? Whatever that.
And that's where we're talking about, like, the TPM path is actually code running on the BMC that responds to the attestation request, just like on a host platform with the TPM. There's code on the CPU that responds and gathers the TPM quote and passes it along to the requester.
Including first mutable code, including the root of trust, that's what you're recommending?
I think you have to have that path if there's no external agent like a PROT.
So let me see if I understand what you're saying. You're saying do not specify having a responder because and use the TPM path even for first mutable code measurements. That's what you're suggesting.
Yes. I mean, I think I'm stating if you don't have a PROT, that is your only path. Like, I don't know where else you get things from if you don't have a PROT to make that SPDM request for you.
Yeah, you could have like an agent running, like somebody mentioned on the call, right? And kind of grab measurements out, and that agent could be the requester. I guess from a BMC standpoint, what you'd say is you want to be able to have return both the, have the TPM quotes, respond to the TPM quotes, as well as be able to respond to first mutable quote measurements. That would be my take. Now, how you do that in your system and as long as it's available from your BMC, we determine that to be kind of secure. You see what I'm saying?
Refresh for 2 minutes.
Sorry, there's a bit of echo or.
Yeah. Sorry, no, I hear. Yeah, there was some echo. I see what you're saying. I just, as far as a requirements doc, I think I don't know if you can require either of them really, because there may be cases where you can only do one or the other.
Yeah.
So you're saying this is an and or.
Yeah. Because I think it depends on how other parts of the platform are designed, like which paths exist and which don't.
But in the end, you do have to send off, like either which way you go, whether it's an and or an or. If it's the or situation, you have to start from first mutable code for measurements.
Yes.
Mm-hmm.
So there would be something in addition to the TPM quote that's capturing the ROT measurements.
Yes.
So you're saying that could be capturing them and putting them in the TPM for convenience sake.
Maybe. I wouldn't go quite that far. That you may need two things, as you're mentioning before, that there may be more than one layer if you're doing it that way.
Mm-hmm.
And I think that's where the responder comes in, right? So I think from a requirement standpoint, we can absolutely say that I don't think there's any dispute on the call where we're saying that we want from first mutable code, we need measurements all the way up, including the root of trust plus the TPM quote, responding to the TPM quotes. I think there's no dispute on that. The question is, how do you, whether or not you require it to be a responder on the root of trust measurements, or use some other path, correct?
Well, yeah, although I would rephrase it slightly, saying that yes, you can definitely provide those lower layers measurements, but another way of dealing with that is if you have verified boot for the TPM, for example, right? You could have a situation where you say, if the measurements are not what I expect, I'm not going to boot that TPM. So then you can make the assumption that if the thing is up, the bottom layers are good, and you don't necessarily have the measurements. Now, I don't know if a lot of people would do that, but it's possible, right?
So you've got something like a ceiling that, as an SEAL, not this roof kind of ceiling, that would prevent your TPM from going any further.
Yeah, well, I was just saying that the lower, one thing that you have to guarantee with the TPM is that the layers that are putting information into the TPM, you have to guarantee their integrity or support protecting them, right?
Yeah.
And one way of telling people that the bottommost layer, let's say, is protected, is by providing its measurement in a PCR, for example, for the TPM. That's one way, right?
Yeah.
Another way is to say, simply, if you're using verified boot for the TPM, if you boot it, that layer is good, right? I don't have the measurement, but if you boot it, it's good. And so then you don't require some mechanism for putting the measurement of that bottom layer inside the TPM somehow, right? Because maybe you don't have a driver yet, or God knows, right?
So which one are you saying is good, the lower layer or the TPM layer? If you get there.
I mean, so the system has to guarantee that the lowest layer before you start using the TPM is good,
Mhm,
right? And that layer
mhm.
will measure the next one and the next
Mhm.
one.
Right.
The way of guaranteeing that that lowest layer is good, one way is by providing that measurement either through SPDM or TPM, right? But providing it in TPM requires some complexity, right? So certain things that you need to do. Or the other way is to say, if this guy is doing verified boot, right? That layer will not be allowed to execute if it doesn't have the right measurements, right? And that's something else in the hardware that is doing that.
Something preceding that lower layer.
Yes.
Well, I
That
mean,
says,
that's essentially the root of trust. Either
Yeah.
you have to measure it and attest it, or it has to be
Mhm.
verified boot. I don't know, like I have an opinion on which of those I prefer, but I don't think that's necessarily material. But yes, you have to have something.
right. So all I was saying is that you don't, it's not just having, the only solution is not just having the measurement in the TPM, or it could be that you're using verified boot. And you just, if you boot it, you know that that layer is good.
I see.
I mean, that does come with the normal caveats about verified versus measured boot.
Right.
Yep.
But then you don't have, it's an implicit measurement, I guess you say, an implicit trust.
Yeah, for verified boot, you typically say, if I'm booted, I'm guaranteed that the layers that were used for booting I'm guaranteed something about the integrity of those layers, right?
Mhm. I don't know that I've captured it. But you don't, if the first layer is mutable, then
Yeah, I mean, I think that, so there's two things of showing that the integrity of that first layer. This is,
Mhm.
you always have to have integrity on that first layer,
Mhm.
right? In order to be able to use the TPM without fear, right? And the two ways of proving that, right, is when you think about verified boot and measured boot, right? One way of proving that is to saying, I expose the measurement of that first layer. So anybody that is going to interact or use the TPM can pull that measurement and say, oh, okay, that the first layer is good, right? But that's a little incestuous in a way, right? Because you're using the TPM to prove that the first layer that it's going to be using the TPM is good, and it's a little weird, right?
Right.
The other way to do it is to say, I just only allow that layer to execute if it is good based on some policies that I have, right? And that's in the hardware. So then in that case, you don't need to have the measurement inside the TPM, for example. You just need to know that if you boot it and you're running, that layer is good.
Well, the alternative for measurement is not necessarily stick it in the TPM. It's maybe you have a dice chain describing that first layer that you provide in addition to the TPM quote, or that is somehow related to the TPM quote.
Yes, I mean, that's what I think in terms of how the cleanest thing is, which is I would use SPDM if I want to get the measurements for that first layer, and not the TPM, right? But you can also not have the measurement at all, just simply use verification, verified boot.
Well, it doesn't even have to be SPDM, right? If you have a dice chain, you can present that through whatever path.
Inside, yeah. You could put it as evidence inside the certificate or something, yes.
Right, yeah. Or just like query that separately. There can be another API for it potentially. But yeah, if the dice chain is there, you can get it by whatever means.
Yeah.
I'm following, I'm just trying to figure out what we should write. Are we still okay with these two statements?
Yeah, I think an and/or works well there.
Can I ask a possibly ignorant question? What to be clear, this is a separate TPM from the main system TPM, right? This is
Yes,
like a second.
yes.
Okay.
On the
Perfect, thank you.
BMC. Mhm.
And is it FTPM or
Either. It can be FTPM or discrete TPM.
so if this is FTPM, then there has to be some way to attest FTPM also, right?
Yes, which they're saying would be then in the SPDM response.
Okay.
Yeah, there's work in TCG for supporting integrity verification of the TPM itself.
Yeah. And then we can use a Calyptra DP for that, right?
Yeah.
So how would Calyptra play into this?
Yeah.
Calyptra would be the ROT
Yeah.
at the
Yeah.
bottom.
All right.
So basically, the Calyptra extend this DICE service to the FTPM through DP.
Yeah, I'm trying to write what this is. So there is DICE is DICE is there, and it measures EFTPM. That's not right. Sorry. It provides the certificate to what measures the TPM. Is that right?
Yeah. So basically, that the certificate binds the FTPM measurement to the root of trust.
Mm-hmm. Yeah. The FTP measurement of the FTPM to the clean up the English, but I think I have the meaning there. Okay. Darpana, you think we are okay drafting these two?
Yeah, I think so. I think we got what we needed here. You and I can talk about some more things if we want to just kind of get some feedback, but I think mainly there's general broad agreement that we want to have a TPM. There's general broad agreement that we want to have a root of trust. There's also for first mutable code. And I think we're also saying that it's FTPM, DTPM either way. Yeah, I think I'm in a good place. The only thing is, what would we do? We also are in agreement that we need to be able to respond to measurements from first mutable all the way for TPM quotes. The question is just how, right? And whether we manage one way or another. So I think we can have a little bit more discussion on that and then propose something if we, and then get consensus from the group, I think.
And from a cloud infrastructure point of view, how would you know which or both of these two to use? Or do you just throw things at the wall and hope they respond and act accordingly?
So Redfish has this notion of trusted components. So I think using that, you can basically understand if it's a DICE-based SPDM attestation that you need to run or TPM-based, probably based on the identity or attestation certificate.
So you would have some sort of registration process or onboarding that would then tell you what kind this device, this BMC is? Is it
Well,
something
yeah,
automated?
that could be one way to do that, yes. You interrogate the BMC to understand if it's going to do attestation using SPDM or TPM or both.
Yeah,
and then you go from there.
Yeah, I think this is related to what we discussed last tweak that attestation features and all those things, right? What kind of configuration is there? What kind of features the platform has?
So it seems like we need some kind of capabilities query of some kind, like what flavor of attestation are you supporting?
Yeah,
I mean,
that's,
if it
So-
were SPDM, it would do it, but SPDM wouldn't talk about TPM.
So there's a couple of things, right? The standard, well, the proposed standard way of talking to a BMC today is Redfish,
Mhm.
right? So Redfish has a couple of calls. There's something called component integrity
Okay.
that and component integrity specifically allows you to retrieve SPDM type measurements from the BMC, right? So I don't know if that call can be used to say, does this BMC support SPDM or TPM? But I think there were versions of that call for both at some point, right? I'm more familiar with the SPDM side.
You can get SPDM measurements, you can get TPM PCRs.
Right.
Potentially the event log as well if you have it.
All right, so there you go. So I think externally, if you want to figure out what that BMC does, if you use Redfish, there's a way to do. That's the way to do it.
yeah,
All
I think
right.
we need to have some kind of, capabilities advertisement kind of message, right? So like, hey, I request, I'm negotiating your capabilities and I want to know what you're capable of. And it needs to respond with something like, I can do both, or I'm doing one or the other, something like that.
Yeah, and I think component integrity, there's a call, right? And it's component integrity, one word. That call in theory should be able to tell you.
So we'd have to add something to the standard to say, hey, make it like this, define something as part of that.
That is a Redfish standard, isn't the standard already? Now, whether or not it has all the functionality that we need, that's something that we need to double check.
Yeah. Okay, I think that's a good call.
Cool.
That's a that's good input. All right, I think that's we got everything we need, I think, Elaine, for today. What do you think?
More that and more. Love this Redfish thing. This is great.
Yeah, this is good. All right, any other
Yes.
questions, comments from anybody else? All right, if there's nothing else, then I think we can call it a day and end early. Thank you, everybody, for all your feedback. Really appreciate it.
Was there actually, sorry, I was on mute trying to talk.
Alright.
I thought I saw something a little farther up about OpenBMC versus other. I don't know if that was like an open question.
Oh, I think we had decided on OpenBMC. Where is this? Oh, here it is. Yeah, we had decided on OpenBMC.
I guess my question is why, and like essentially what's special about OpenBMC versus, using some other Linux distro as the base?
Yeah, and that goes as another question, which is, do you care about the OS inside? Because, I view them as separate things, like what's the OS inside and what's this OpenBMC is, in addition to that, it is an interface as well, right? I think
You're talking about OpenBMC as the set of
application.
APIs and not necessarily the OS inside.
Right.
Okay. That makes sense then for this one, and I guess I don't know, like the answer about what is the OS underneath that interface was that not specified, or was there?
That was not specified. We never got to that one. That's number 5.
That's, yeah.
You have input while we're on it?
I mean, my only real thought there is, you know, I'm going to use Linux as an example because that's easy. There's lots of like OS security guidelines for Linux in various forms for various classes of systems. It feels like it would be redundant to try and redefine that versus pointing at what the, you know, existing thing that we think is appropriate for this class of system is. Like, I don't know if you want to go to the detail of like defining OS security settings specifically for BMC, or if there's just an existing one you want to point at. Because that's like a huge project all of its own.
Yes. Yes, I agree with you that it's a huge project all of its own. Yeah, you could, because there are, you know, there are so many other, not so many, but there are other trusted OSs, you know, that you could put inside there if you want to. Things even with certifications and formal proofs and all kinds of other, you could really go crazy. So I think what you're saying then is we don't want to mandate what's inside as far as the OS goes. Yes?
I think probably not, but I think what you want to require is, you know, regardless of the OS, some sort of known level of appropriate hardening for that OS, right? Like I know there's a bunch of guidelines out there for Windows and Linux. I don't know what exists for other things, but I feel like this is more a requirement on like, regardless of what you've done here, you know, here are the places you should go and make sure you are complying with proper OS hardening and guidelines.
Yeah.
As opposed to trying to rewrite them, because I feel like that's a never-ending rabbit hole to go down.
Oh, I see.
Yeah, I wonder if SE Linux is something that would be a good reference.
Right.
I mean, the problem with SE Linux is now, like, what is your rule set? Right? Just like everything, it's saying use SE Linux is not sufficient, because I can write one rule that just allows everything and it doesn't accomplish much.
Yeah, but I wonder if you could say something about support the level of protection that can be obtained with something like SE Linux.
Again, that's hard because there are, if you go down that rabbit hole, there are many competing opinions on OS hardening, and there's opposition to SE Linux in some places and preference for other things. At the end of the day, I don't know that this group wants to get involved in that.
Yeah, but the question is, should we give guidance 2 or 3 environments like that? Or I know it's really, really hard, right? But
well, I mean, there's things like CIS benchmark, and there's other things that I can't remember the names of off the top of my head, but like there are guidelines out there for OS hardening. There's a bunch of, if you're talking about Linux specifically, there's a bunch of OS hardening guidelines. There should, maybe there isn't, but I feel like there should be something out there that we can just refer to saying, if you're using Linux, make sure you are complying with this benchmark.
Yeah.
Or you are complying with like one of these like acceptable benchmarks, right? It doesn't even have to be narrowed down to just one. We can point at like, here's several different benchmarks. Make sure you're complying with at least one of them. The only requirement is really you cannot comply with no security benchmarks. You have to go through and do something to demonstrate that you've configured this underlying OS in a reasonable fashion.
How are we going to come up with this list? And everybody volunteer at once.
I can go find a couple that I know of for Linux. I don't know of any BMCs running Windows, so I don't know if we need to go get one of those.
No.
And I'm not super familiar with other OSs being used under BMCs.
Yeah, I think Linux sounds like the right place to go. I haven't heard of anything running Windows, so it's reasonable.
Okay. I can go find a couple of the more popular ones and we can figure out who wants to argue over which is the appropriate one.
I think we should take one that is the, there's not only a perfect one. We should take one that we believe is the most secure and propose that, right? And then, or propose maybe two.
Yeah.
Maybe like
I mean, CIS is one of the more popular ones. It's also not necessarily the most comprehensive one. But as you go down that rabbit hole, things become more restrictive, and I don't know at what point the configuration and the hardening start to interfere with the things the BMC is trying to do. So
yeah.
Maybe
what the right threshold is.
Yeah, maybe we recommend the minimum, right? And say this is the minimum you can do, and then people are welcome to go above that, depending on their, depending on the threat models and other stuff.
I like that idea. I think that makes sense. Let's take this up. If you can get us back the information and your recommendations offline, maybe we can take this up and we can consolidate our viewpoints and bring that back and close this one out for the next one, for the next meeting, whenever that is. Okay.
Sounds good. Thank you,
right.
everybody, for your feedback.
Thank you, everybody.
Yep. Bye-bye.
Thank you. Bye.